What's up everyone, and thank you for choosing to learn with LAM. Today we're going to put the final piece into our stoichiometry puzzle by finishing it all off with percent yield. First off, a couple definitions. Theoretical yield is the amount of product that is calculated to be created under ideal conditions. So essentially, what's supposed to happen. This value is typically calculated through stoichiometry. Experimental yield, on the other hand, is the amount of product that is created as the result of a lab experiment, so what actually happens. This value will be given to you in a question, or you'll find it by doing the experiment yourself. Now, the percent yield equation itself is pretty straightforward. Percent yield equals experimental yield over theoretical yield times 100%. This equation works with both moles and mass, so you could have percent yield equals experimental mass over theoretical mass times 100%, or percent yield equals experimental moles over theoretical moles times 100%. What complicates things a little is utilizing it in a stoichiometry problem and making sure you know what you're looking for. So let's jump into a sample problem here. What is your percent yield if you produce 10.0 grams of aluminum oxide from 10.0 grams of aluminum and 10.0 grams of oxygen gas? I'm going to go through the stoichiometry and limiting reactants part of this question pretty quickly, so if you need a bit of a refresher, both tutorials can be found in the description below. But as always, we're going to start with a balanced chemical reaction. So we've got aluminum plus oxygen makes aluminum oxide, and to balance that, we have 4, 3, and 2. My givens are 10.0 grams of aluminum, 10.0 grams of oxygen, and 10.0 grams of aluminum oxide. Now, this is where some students tend to get a bit stuck. It looks like we have all the information we need, so what are we solving for? Just a reminder that we're looking for percent yield, and that the mass of aluminum oxide we've been given is the experimental mass. So what we need to find is theoretical mass, which we do through stoichiometry. So as usual, let's find moles using mass and molar mass. That gives me 0.370645 moles of aluminum and 0.3125 moles of oxygen. Remember that to find limiting reactant, I need the relative values of each reactant, so I need to divide by the coefficients. 4 for aluminum and 3 for oxygen, which gives me 0.0927 and 0.1042. Notice that I don't use the mole unit because these numbers aren't moles. Anyway, aluminum is my limiting reactant, so I'll ratio the moles of aluminum over to aluminum oxide. It's a 4:2 ratio, so I have 0.1853225 moles of aluminum oxide. The molar mass of aluminum oxide is 101.96 grams per mole, which gives me 18.895 grams as my theoretical mass of aluminum oxide. Again, my theoretical mass is how much I should make under ideal conditions. Obviously, there were some errors involved since I apparently only obtained 10.0 grams experimentally. Anyway, to calculate percent yield, I simply substitute in my experimental and theoretical masses, so 10.0 grams divided by 18.895 grams times 100% gives me 52.9%. And that's all there is to that. As always, if you have any questions, just leave them in the comments below. Good job, everyone. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.